My name is Christian von Koenigsegg. For half of my life, I've been on the quest to be a leader in the hypercar industry, utilizing Swedish design combined with visionary technical solutions. Koenigsegg is a company known for developing extreme technology for hyper and mega cars and so on. But a lot of the stuff we're doing, and especially our sister company Freevalve, is now trickling down into also more normal cars. And with the Freevalve technology, for example, here's a typical example where supercar technology can also work well in a normal car. For example, we're using our Koenigsegg engine management system to run these engines. And we have this kind of throwing backwards and forwards of ideas that works just as well in a normal car as in a hyper mega car. What we're looking at here is a customer project we're doing where we are taking an existing 1.6 liter turbo engine producing 160 horsepower and 240 newton meters of torque. It has port injection, not direct injection. It's for a Chinese car brand called Coros. It's a quite modern engine they have. It's developed in Germany and Austria 5-6 years ago, so it's not something out of date or anything. But it's at the same time a good base to revamp for the next generation of technology. So what we did, we got the CAD drawings for that engine and changed what we needed to change to make it into a Freevalve engine. And what we're looking at here is the main part of that revamping, and that's the cylinder head. So this is the original Coros cylinder head, which is very contemporary looking and equivalent to most modern 1.6 liter four-cylinder engines. We have stacked this up on a box here, which is pretty much the same height as these rubber cushions which this head is standing on, just to show you the height difference of the cylinder head. Lowering the engine is very important to car manufacturers, and here we managed to lower, not only increase the functionality of the cylinder head, but also lower the cylinder head with about 50 millimeters. And it's also 70 millimeters shorter and narrower. So all in all, the engine shrinks due to the fact that the cylinder head is so much smaller. Then we don't need the camshaft drive here either. Here, this is just, we don't need that. I mean, we have pneumatically operated actuators in here, so that also shortens the whole front side of the engine and the FIA, the drive, belt drive in the front of the engine. All in all, the engine is about 15 to 20 kilos lighter depending on specification, which is very big difference. So there's a lot of raw material savings there. But most important, of course, is the fact that we get free control over the valves, so we can operate each valve individually, and that really improves the combustion process drastically. So with the Freevalve technology, each valve can be held at a certain position, decided not to be lifted, or fully open and held there as well, individually from each other, timing-wise, individually, completely. So we take benefit from that. So you can see on the intake side, and it's the same on the exhaust side, there is one port for each valve. And you can also see the port shapes are a little bit different, because when we run in one intake valve mode, we get different tumble and swirl effects, so we need to adapt to that a little bit. And we can also operate the exhaust valves individually, and we can shut down cylinders, of course. As you can see on the dyno test we're doing with this engine, we have separated the exhaust ports, so every other exhaust port goes straight out into the exhaust, and every other one goes to the turbo. That means we don't need a wastegate, because we can control the turbo pressure with the opening of the turbo valves and how much we bypass straight out into the exhaust. And as we bypass every other valve straight out into the exhaust, the total back pressure can be lower on average, And we can heat up the exhaust system and the catalytic converter much better in cold start than any other turbo engine, partially because we're bypassing the turbo, and partially because we can combust in a completely different way to shoot out long flames in the exhaust during cold start. So that way we can remove, we have no need for the pre-catalytic converter anymore. The pre-catalytic converter is only there for the cold start, really, to get hot quickly. We can heat up the main cat as quickly, so we can save a lot of money by removing the pre-catalytic converter. Also, as we have free control over the valves, we can throttle inside the combustion chamber. So many of you know how a race engine have a small plenum volume with a throttle to have good response, or even a throttle on each intake tract to have very little volume behind and to have a good response. We're actually throttling inside the combustion chamber, so there is no way to get better response than that. On top of that, we have less losses in the intake, because we don't have to pull under pressure in the intake between the throttle and the engine. We can have atmospheric pressure there, or overpressure with turbo. So that alone saves around 4 to 5% of fuel consumption. And again, it saves weight and cost, because we don't need a throttle body. The final kicker, I would say, is that we don't need direct injection. We're running a turbo engine here with 12:1 in compression ratio, or maybe even up to 14:1 in compression ratio. This one is down to 9:1 in compression ratio, which is normal for a turbo 4, I would say. So higher cylinder pressure than any directly injected turbo engine with port injection. And the benefit of port injection compared to direct injection is that it's much cheaper, because you're running at lower pressure. It's higher volume production still, so it's cheaper due to that. And you avoid getting particulates into the exhaust, because you get cleaner combustion with a more controlled combustion of the fuel entering in the cylinder. The advantage of direct injection is that you can cool the cylinder, and that's good for a turbo engine. But we can cool the cylinder in other ways by flushing it and spooling it between the cycles. So there isn't really any benefit for us to put direct injection, but there's a huge cost saving, and we don't have the particulates problem. So in the end, what does this do for the engine in this case? So in our dyno testings and our simulations, we're seeing a huge increase. I mean, we still have a small production turbo here, but we're seeing a huge increase in torque, 47% torque increase. From 240 Newton meters to 320 Newton meters of torque. 45% power increase from 160 horsepower to 240 horsepower. Fuel consumption saving of around 15%. Emission reduction of around 35%, mostly due to a much better cold start. Usually any combustion petrol engine, as soon as it's warm, is very, very clean. As soon as the catalytic converters are warm and the combustion chamber is warm, it's very little pollution. But during the cold start, you have a lot of pollution. And this system really improves the cold start drastically. So yeah, huge saving in every aspect.